everyone, welcome to my vlog, and in this video we are going to talk about theorems related to chords, arcs, central angles, and inscribed angle. And I'm gonna be using the SLHT as the reference guide in this discussion. And to start with, we are going to talk about the theorems on central angles, arcs, and chords. So I will not be going to discuss the details about the proof, but I'll just be showing to you using this figure on what does this theorem is saying about. Okay, so to start with, let's have theorems on central angles, arcs, and chords. Okay, so first theorem about central angles, arcs, and chords, we have if two central angles are congruent, then the corresponding arcs are congruent. No, when we say congruent, they are alike, no, in measurement, and they have the same degrees, no. And when we say corresponding minor arcs, it refers to the intercepted arc. If you try to review the terms related to circles, I have also discussed there, and also the video about central angles and its intercepted arc, and also inscribed angles and its intercepted arc. You could see there what an intercepted arc is all about. And it states that two central angles are congruent, then the corresponding minor arcs are congruent. So using this figure, this one, as you can see, we have circle A, and we have angles PAL, that's PAL, and angle TAO, no? So they are two central angles, and from the given, they are actually congruent. So this is the symbol for congruent. Okay, so it means that, for example, if this angle PAL measures like 50 degrees, then TAO is also 50 degrees because they are congruent. So since the two angles are congruent, they have also this intercepted arc. So the intercepted arc for angle PAL is arc PL, that's the minor arc, and also for TAO is also a minor arc, right? So if this is angle PAL is 50 degrees, therefore the arc PL is also 50 degrees because central angles and its intercepted arc are congruent, or they have the same measure. So if angle PAL is 50 and then TAO is also 50, therefore arc TO is also 50 degrees. So that's what this theorem means. So if the two central angles are congruent, so of course their corresponding minor arc is also congruent. Now let's go to the converse of theorem, meaning the opposite. So if we have two congruent arcs here, their central angles, corresponding central angles, is also are also congruent. No, so that's just the reverse, no, converse. That's why it's converse of theorem number 1. Now let's go to theorem number 2. So we have here circles O and circle E. So these two circles are congruent based on the given. And another one is chord AB and chord CD. They are also congruent. So the theorem states that if two chords are congruent, then their corresponding minor arcs are also congruent. So here we have arcs AB. So their intercepted arc is arc AB. And then chord CD, the intercepted arc is CD. So since chord AB and chord CD are congruent, therefore their intercepted arcs are also congruent. And if the given is the intercepted arc and then the two are still congruent, therefore chords AB and chords CD are also congruent. So it's just the converse of theorem number 2. Okay, so now let's go to theorem number 3. So in a circle, this one, circle D, a diameter, this one, LU, that's LU, diameter, bisect. When we say bisect, bi means two. Sec is to cut. So it cuts two equal parts because bisect. So it cuts two equal parts. That's bisect means. So diameter bisects a chord and an arc with the same endpoints if it is perpendicular to the chord. When we say perpendicular, the angle formed of the intersection of the two is a right angle. So when you see this symbol, this one likes a little square, it means perpendicular, no? So this is diameter and this is the chord. A diameter bisects a chord if it is perpendicular. So since line segment LU, the diameter, and line segment ME, the chord, intersects each other and form a right angle, so they are perpendicular. Since they are perpendicular, the line segment form, this one, MO and OE, are congruent. They have the same measurement. And not only that, we have here also an arc. This one, arc ML, an arc LE. So, since diameter is perpendicular to the chord, it also bisects the arc. So meaning, arc ML is congruent to arc LE. So for example, if the measure of ME is 10, since the diameter bisects the chord, it forms right angle, this symbol. So this is 10. Meaning MO is 5 and this one is also 5. So if arc ME, the entire arc ME is 100 degrees, and since the diameter bisect, so arc ML is 50 degrees and arc LE is also 50 degrees. So that's the meaning of this theorem. Okay? So now let's go to the theorems on inscribed angle. Okay. So number 4, or the first theorem, and the number 4 in continuation. The measure of inscribed angle is half the measure of the intercepted arc, no? So for example, we have here inscribed angle, then it's intercepted arc PR. So if the arc measures 100 degrees, the inscribed angle is equals to 50 degrees because the angle is 1/2 of the arc. So that's the meaning of this. And or it means that the measure of intercepted arc is twice the measure of inscribed angle. So for example, the given here is the inscribed angle. So the angle here is 60, the inscribed angle. So what is the measure of the arc? The measure of the arc is twice, so it means 60 times 2. So that's 120, okay, degrees. Okay, so intercepted arc is twice the measure of inscribed angle. So it's always bigger than the inscribed angle. Okay, next is if an inscribed angle intercepts a semicircle, then it is a right angle. So all we know that the entire degree of a circle is 360. And when we say semicircle, it is half. So half of a circle, half of 360 is 180 degrees. So meaning this arc JN is equals to 180 degrees. And we have here inscribed angle. Since inscribed angle is 1/2 of its intercepted arc, meaning this is 90 degrees. No, 1/2. 1/2 of 180 is 90. And 90 degrees is a right angle. And this is the intercepted arc is a semicircle. Okay, that's it. Next is if two inscribed angles of a circle are congruent, intercept the same arc. So for example, we have inscribed EJS and EOS. They have the same intercepted arc. So what can you say about their measure? So since they have the same intercepted arc, their measure is also the same. So that's why it's congruent. Next, we have number 7. If quadrilateral is inscribed in a circle, then its opposite angle are supplementary. I have already discussed this in my previous video. We have an example also. So it means that the measure of this angle plus this angle is equals to 180 degrees. The measure of this angle plus this angle is also 180 degrees. The total is 360 degrees. So that's all for the theorems. And to see an example activity with that, I have here, I got this example from the SLHT that I have, but I'm gonna change this one 4 into, let's say, 3. I'm gonna change 50 degrees to 55 because I don't want to give you the exact answer for your activity. I'm just gonna be using another number, so you're gonna be solving it on your own. Okay, so now we have here the theorems on central angles, arcs, and chords, and the theorems on inscribed angles. Okay, so here we have here in circle C, so we have circle C, then line segment CZ, this one and to this one, is perpendicular to RS, this one and this one, so it means perpendicular. Okay, so from the given that it is perpendicular, we can have a reference here, right? In a circle where a diameter bisects a chord and an arc with the same endpoints, if it is perpendicular, so, and it's, even though it states here that's a diameter, but if you try to extend CZ to the opposite side, that becomes a diameter because CZ is a radius, right? Okay, so let's continue. Line segment TS, the distance between TS is 3, okay? And the measure of arc CS is 55, okay? Okay, so in reference to this number 3 theorem on central angles, bisects a chord and an arc. So when we say bisect, it divides 2 equal parts. So meaning, since we have here 3 for ST, so the other one, they are congruent because it bisects, say perpendicular. So this will also become 3. And SR will also be 55 degrees, right? From this theorem, no? Okay, so let us now try to answer. What is the measure of line segment RS? So the measure of line segment RS is equals to the measure of line segment ST as the measure of line segment TR, right? Because if you try to connect them, if you try to connect ST and TR, it becomes RS. So 3 plus 3 is equals to 6. So number 1 is 6 centimeters, right? Now let's go to the measure of RZS. Arc RZS, no? So using the arc addition postulate, so the measure of arc RZS is equals to the measure of arc SZ plus the measure of arc ZR, which is equals to 55 degrees plus 55 degrees is equals to 110 degrees. Therefore, our answer for number 2 is 110 degrees. Now, what is the measure of angle CZS? Remember, this is a central angle, no? And central angle has the same measurement as to its intercepted arc. So here this is 55 degrees, therefore central angle is also 55 degrees. So that is 55 degrees. Now let's go to number 4. Measure of angle RSC. So let me erase. Measure of angle RSC. If you try to extend that, it becomes an inscribed angle. And we need to have the measurement here, right? We know that arc SR is RZS is 110 degrees. What is the measure here? We know that this one is a semicircle because this is a diameter, right? So that's 180 degrees. Then we don't know this. What are we going to add to 110 to become 180 degrees? So we would subtract. So that's 70 degrees. So meaning this one is 70 degrees. And this is an inscribed angle. Remember that it is 1/2 of the measure of its intercepted arc. So meaning 70 divided by 2, this is 35 degrees. So the answer is 35 degrees. So that's how are you going to apply these theorems to the given problem, no? You read the theorems, you understand them, and you apply them. Do not forget them, okay? And you try to analyze the figure before applying them and what theorem are you going to apply, okay? So do you have any question? I hope you learned something from here. Take note that I have changed the given. So these are not the right answers to your activity, but this will be just the answer for this given, okay? So that's all. I hope you learned something and enjoy answering your activities. Bye bye, love lots, moi.